Okay, thank you, Chairman. Good afternoon, ladies and gentlemen. I begin by acknowledging the contribution of my co-author, John Bailey, and also many other AFBI staff have provided me with information for this presentation. We all know the UK voted to leave the EU back in June last year, and that has created a large amount of uncertainty across a wide range of issues, especially for trade. A key principle behind the EU single market is the free movement of goods, people, services and capital. In relation to goods, goods can move freely within the EU without being subject to tariffs, quotas, duties or custom delays. And the impact of Brexit on the UK's ability to trade within the EU is unknown. The EU also has free trade agreements with many other countries, and the impact of Brexit on our ability to trade with these countries is another unknown. This figure was mentioned earlier on today. This is food processing sales for milk and milk products for Northern Ireland. And I think the key value here is that 46% of sales of milk and milk products from Northern Ireland are outside of the UK. Of that, approximately 40% is to the EU and 6% to the rest of the world. So that really leaves 46% of the value of our dairy products with a question mark against it in terms of what happens post-Brexit. There's no doubt, and I'm sure everyone in this room agrees, that exports will remain critical to the success of our dairy sector in the future. And I think the key thing here is our government must seek to achieve highly favourable trade agreements with the EU and with other EU countries. How that will be achieved, what that will look like, is way beyond my remit here. The next speaker, John Davis, will give us some insight to some of these issues. But the premise of my presentation here today is that this will be achieved. We will get favourable trade agreements. We will be able to sell our dairy products, and our dairy sector will be sustainable. Really, the question that I want to look at is what standards will we have to meet in order to export our dairy products? If we just look at a couple of countries here, GB to start off with, where there's a large deficit in dairy production, huge opportunities for Northern Ireland to export dairy products into GB. And really, I think if we're going to do that, the standards we're going to have to meet to do that will need to exceed what we currently have at present, bearing in mind GB standards currently similar to our own. With regards EU, I think bear in mind the statement that was made by Commissioner Hogan in a meeting in Dublin earlier this year in relation to Brexit, and that was we will not compromise our standards on the altar of trade. I believe if we're going to trade within the EU, continue to trade our products to the EU, we need to certainly meet all the current standards that we currently have and probably go beyond that. With regards to trading with the rest of the world, well, certainly we all know that there's a lot of dairy produce sold on world markets that's of a much lower standard or produced at a much lower standard than what we produce within Northern Ireland. But I don't think anyone in this room would believe that's the route that we need to go down, that we plan to go to the lowest standards to access world markets. We do need to access world markets, and we need to be accessing them with high quality product that we can actually declare as high quality as a marketing opportunity. In reality, we need to maintain and expand our export markets, and to do that, Northern Ireland must seek to produce milk which meets the highest standards in relation to animal health, welfare and the environment. That will also, I believe, give us some protection from third country imports. So what are the challenges to our environmental credentials? I have three up here. Firstly, improving water quality, an area that we're probably all familiar with. The second is reducing atmospheric nitrogen deposition, which our previous speaker alluded to. The final one is greenhouse gases. Because of time, I'm not going to really deal with the greenhouse gases here today. AFBI has carried out a lot of research over the last sort of 5-6 years on reducing greenhouse gas emissions, and that has been published at other places. So really I'm going to begin by focusing on improving water quality, and most of this part of the presentation will be about phosphorus, which we have heard the Dutch experience of just now. I begin with this slide, which shows soluble reactive phosphorus levels in 127 Northern Ireland rivers, NIEA data, from 1998 through to very recently. And you can see until recently, P concentrations in Northern Ireland rivers had been declining. And that made it easier for us to justify no further tightening of our nitrates action programme whenever we dealt with the European Commission. However, you can see the red circle, the dotted circle, in the last few years, which has shown that P levels appear to be rising, and this is certainly a major concern for us in Northern Ireland. So why is that? Why are we getting this beginning of an upward trend in the P levels in our waterways? Well, I think if we look at the P budget for Northern Ireland, which is summarised here from 1990 to 2015, it gives us some idea of what's happening. If we look firstly at the green line, which is the P surplus, you can see that the Northern Ireland P surplus halved between about 1995 and 2009. And that was, 2009. And that was really due to the reduction in phosphorus fertiliser use, which is highlighted by the blue line on the graph here. However, over the last sort of 5 or 6 years, the P surplus has started to rise again, and it's now gone above the 10 kilogram P per hectare level, which we consider critical. Reasons for that, you can see, is a slight increase in the use of phosphorus-free P fertiliser again, and also the continued increase in P coming onto farms in concentrate feedstuffs. So what are the possible implications of the decline in water quality? Well, the European Commission could insist on new measures to tackle the problem, and these might include extending the close period for slurry application. That's something we were challenged with a number of years ago, and AFBI research, based on a survey of Northern Ireland farms, demonstrated that actually a relatively small proportion of our total slurry was actually spread during the month of February, and that we were able to present that evidence to the EU to demonstrate that February wasn't a risk month, but it could come back to us. Also, banning slurry application on high P soils has already happened in a number of countries in Europe. And when you consider that on average 70% of fields on intensive dairy farms in Northern Ireland have an index of P or greater, the impact for those farmers of not being able to spread slurry in those fields would be absolutely catastrophic. We could impose P balance limits on all farms, again, as happened in some European countries. And I might say that that is something that's maybe difficult to defend. Why not? Derogated farms can survive with a P balance of 10 kilograms of P per hectare. Maybe all farms should be able to do that. Ultimately, the EU or the Commission could refuse the renewal of our derogation from the Nitrates Directive in 2018, and we've just heard of the implications of that for the Netherlands. At present, we've got 308 derogation applications for 2017 in Northern Ireland. Those numbers have been increasing slowly, and certainly I suspect that many other farms should have a derogation. Any of the above will have major implications for the Northern Ireland dairy sector. But if water quality does not improve, legislation will force change. Really, the question is, how can we tackle the problem of declining water quality? We have heard what has happened in the Netherlands, and I don't think anyone in this room would be thinking that a reduction in animal numbers is a route that we want to go at present. The biggest issue for Northern Ireland is our P surplus, and we need to reduce the amount of phosphorus that we bring onto farms. It's as simple as that. There are other solutions which I'll say a little bit about exporting phosphorus, but the key issue we need to tackle is the surplus. We need to reduce the amount of phosphorus coming onto farms. So how do we do that? I have a couple of slides here that just highlight how we might do that. Firstly, we can reduce the amount of inorganic fertiliser phosphorus coming onto farms, and in reality, few Northern Ireland dairy farms require inorganic fertiliser phosphorus for their grasslands. There are, of course, exceptions. There are low concentrate input systems, especially spring calving systems, where P surplus may well go below 5 and below 0, and they have a requirement for P. One of the biggest issues we have is that the P is not well distributed or recycled on our farms. And this map highlights the main farm is in the centre, and you can see the fields very close to the farm have very high P concentrations. Those further away have much lower P concentrations. So really there is a problem with redistributing and recycling manures. We also know that some fields are unsuitable for manure because they're too wet or they're too steep, but the whole problem is compounded by a lack of soil testing. The second strategy, and again we've heard about the Dutch approach here, is reducing the amount of P onto farms by using low phosphorus concentrates. And AFBI research has demonstrated that it is possible to reduce P levels in dairy cow concentrates without a negative impact on performance, but the question always is, how low can we actually go? Back in 2001, when this research was established, we surveyed farms, and the average P content of concentrates at that stage was about 6.2 grams per kilo fresh. Back in 2005, the industry, on the basis of our results and their own evidence, came up with a figure through NIGTA of 5.7, which the industry then adopted. It was a start to reducing P levels in our concentrates. And speaking to the industry now, the figure that I'm often told is that diets contain probably closer to about 5 grams of phosphorus per kilo fresh. The research at Hillsborough showed that we could operate with our P content in our concentrate of 3.8 grams per kilo fresh. So certainly there is scope for our industry to further reduce concentrate P levels below 5 grams per kilo fresh. But certainly there could be cost implications for that. And also, as we've already heard, we then need to begin to consider the P content of the silages, because it can be extremely variable. So we need to balance the rations much more carefully for phosphorus. But I've no doubt that further reductions will be necessary on some farms if they are to achieve sort of a sustainable P system on their farms. Just to demonstrate that it is possible, a P balance of 6 kilograms per hectare was achieved in a research project at Hillsborough using highly stocked derogated farms producing about 9,500 litres of milk from 3.5 tonnes of concentrate through the use of a zero P fertiliser policy and through the use of low P concentrates. So this is an approach that we probably have to adopt, but one with a possible cost. I think the one that I think is really the approach that we need to use, really focus on, is making more efficient use of concentrates. And I think probably many of you are familiar with this sort of figure, which is from CAFRE benchmarking. It shows the relationship between concentrate intakes and milk production on the farm. And you can see there's a huge spread of points here. Each point represents a farm. There's a huge spread of points. And really the farms that are on the upper side of the dots are the most efficient farms, and the farms on the bottom side of the dots are the least efficient farms. So what's the impact of that on P surplus? Well, really we've just modelled this. So taking farms with milk yields between 6,000 and 7,000 litres, and looking at the most efficient and the least efficient 25% of farms within those milk yield brackets, you can see the most efficient farms have a P surplus of 3.6 kilograms of P per hectare. The least efficient farms have a P surplus of 12.6. Similarly, if we look at what happens between 8,000 and 9,000 litres, the most efficient farms have a P surplus of about 9. The least efficient farms have a P surplus of 17.9. So this really shows you that by making more efficient use of concentrates, there is real potential to reduce P surpluses. And that'll be accompanied by significant economic gains as well as environmental gains by making more efficient use of concentrates. The key way by which we must do that is by making more use of quality forage. And Debbie has alluded a little bit to that this morning. There are, of course, management practices to reduce P runoff. And I think the first thing we have to accept is that dairy cows will never use phosphorus with 100% efficiency. Cows will always excrete some phosphorus in their manures, so really we need to take action to minimise the risk of that phosphorus being lost to waterways. Our nitrates action programme is designed to do that, but of course we probably can go further. And there's research in AFBI looking at other approaches, such as the use of LiDAR maps to map overland flow pathways. LiDAR combines land elevation, hydrology, and soil information to indicate where the risk of P runoff is the greatest. And this map here in the bottom right-hand corner is for one of the fields going up to the avenue to Hillsborough. It's a field with a large hill on it, and LiDAR has indicated that the orange area is the area of that field where there's the greatest risk of phosphorus being lost in runoff. And that allows us to put buffer strips in there. I think in fact we need to remember there's research from the south of Ireland that has shown that it's probably only 5 to 10% of the land in the country that is responsible for the greatest amount of phosphorus runoff. So those areas can be targeted. And that's probably an opportunity with Brexit to allow us to come up with very targeted strategies to tackle these specific areas rather than maybe the very broad brush approach that we've been using at present. Exporting P off farms, again, we've heard that it happens in the Netherlands. Phosphorus can be exported from farms as raw slurry, and certainly there are local opportunities to do that. but there's probably limited scope for mass redistribution around Northern Ireland, and that's something that my colleagues have modelled. There's obviously the animal health issues, but there's really the risk that we'll move phosphorus to an area where there's currently good water quality and result in a deterioration in water quality in those areas. Technologies do exist to process manure, to extract phosphorus from that, and to move that phosphorus off farms. And some of these are highlighted on the right-hand side. They run from very simple systems that are probably relatively inefficient at removing P to highly efficient systems. But the more efficient you get, the higher the cost. There also has to be an export market for that, and at present that's something I don't believe we have in Northern Ireland. So exporting P off farms on a large scale may have a role in some situations, but I don't believe it's going to be a Northern Ireland-wide solution. I come back to one of the first statements that I made is the key issue we need to do in tackling the phosphorus issue is reduce our phosphorus surplus. We need to bring less phosphorus onto our farms. I'm going to move on to fairly briefly to the second area which I'm covering in this presentation. It's probably an area that's much less familiar to most of us, certainly an area that I'm no expert on, and that is reducing atmospheric nitrogen deposition. By atmospheric nitrogen deposition, we're really talking about reactive nitrogen, which is emitted to the atmosphere and then deposited on land or water bodies either as wet deposition or dry deposition. So what do I mean by reactive nitrogen? Bear in mind that about 80% of the atmosphere is nitrogen. Reactive nitrogen is really nitrogen in a form that's usable to plants. And within the UK, the main forms of reactive nitrogen are nitrous oxides, mainly from fossil fuel production, and ammonia, approximately 85% of which is from agricultural sources. Why are we concerned about reactive nitrogen and nitrogen deposition? Well, when it's deposited on sensitive habitats, it causes acidification of the soil, it causes eutrophication, nutrient enrichment of those habitats, and that results in a loss of biodiversity of plants, fungi, mosses, lichens, etc. Atmospheric nitrogen also contributes with particles in the air, which then can cause respiratory problems as a public health issue as well. So two very major reasons why we need to look at this. Legislation already exists. There's the Gothenburg Protocol, which is more of an international agreement, and also the EU National Ceilings Directive. And there are also lots of specific directives targeting habitats within EU legislation as well. So what does the picture look like? Well, this is information that I obtained from the Centre for Ecology and Hydrology website, and it looks at nitrogen deposition and ammonia concentrations. If we look at the first UK map, and you can see that in terms of nitrogen deposition, large parts of Northern Ireland have nitrogen deposition levels of greater than 15 kilograms of nitrogen per hectare per year. Compare that to other parts of the UK, and you can see that we appear to have quite a major problem. Northern Ireland is actually responsible for 11% of the UK's ammonia emissions. That's about 4 times higher per capita in Northern Ireland than in the rest of the UK. In terms of what are critical levels, what are critical loads, well, approximately 90% of sensitive habitats in Northern Ireland exceed the critical level for nitrogen deposition in 2011-2012. Also, the map on the right-hand side shows ammonia concentrations. And again, you can see that large parts of Northern Ireland have ammonia concentrations of greater than 1 to 2 micrograms per meter cubed of air. The impact of that is that critical levels for some very sensitive plants, such as lichens are around 1 microgram. So we certainly have an issue here as well. In terms of ammonia emissions from livestock systems, I just put up this figure to bring it very close to home. I've already said that Northern Ireland is responsible for about 11 or 12% of UK ammonia emissions. This is data that we record at Hillsborough as part of monitoring for the Centre for Ecology and Hydrology. And you can see the large peaks and troughs here. I think this data went for over about the last 10 years. You can't see the scale, unfortunately. But quite often the troughs in this data correspond to periods whenever the closed period is actually in progress. So 80 to 90% of agriculture ammonia emissions are from manure. And emissions take place at all stages of manure management. They take place during housing, during manure storage, and during spreading. But I think the key point I want to make here is that abatement to reduce ammonia losses at any one point here can simply result in nitrogen being maintained in the manure and subsequently lost at another stage. So we need to, if we're trying to abate ammonia losses, we need to look at housing, we need to look at storage, we need to look at spreading. We need to look at all strategies here. But before we actually go down that route, I think one of the most effective strategies that we need to consider to reduce ammonia emissions is manipulation of the diet to produce lower emitting manures. In terms of diet manipulation, most ammonia from ruminant diets or from ruminants actually comes from urine nitrogen as opposed to feces nitrogen. This is data that Chan Hai-Yan from a colleague at Hillsborough produced from his chamber data, involving about 1,000 dairy cows, which clearly shows that as protein levels increase, the proportion of nitrogen excreted in urine increases, and that is the part of the feces that is most susceptible to being lost as ammonia. We haven't actually conducted research in Northern Ireland as yet looking at the impact of diet on ammonia emissions, but this was research from Sweden which clearly shows that reducing protein content of the diet from 17 to 13%, which unfortunately resulted in a reduction in milk yield in this study, reduced ammonia emissions from fresh manure by over 50%. So certainly there is scope to reduce ammonia, and that can be done by both reducing the protein content of the diet, which should reduce costs, also improving protein degradability. And I believe there is scope here in Northern Ireland for us to do our own research with our grass silage-based diets. In terms of ammonia mitigation, I've already mentioned housing for that. And again, other research has been conducted by colleagues at AFBI from Agri-Environment branch, looking at strategies to reduce ammonia emissions from slurry in housing. This research involved our chambers where slurry was put on the ground, treated with additives. 10 potential additives were examined, and you can see in this slide one of the additives, an acidifier, and I'll not mention the name of that because the data hasn't been published as yet, was highly dramatic, the blue line on the figure, in terms of reducing ammonia emissions from slurry compared to the control system. And there are lots of other approaches. I'm sure many of you have been to the calf-free dairy unit and seen the slats there that are again designed to reduce ammonia emissions. Lots of approaches can be taken. Also, in terms of reducing ammonia from slurry stores and following spreading, one of the key strategies here is to put a cover on them. Covers on slurry stores can reduce ammonia emissions by up to 80 to 90%. And again, there are other approaches can be taken. With regards to slurry spreading, trailing shoe approach, timing of slurry application, again, there are very simple management strategies. I don't have time to go into the details of these, but simply to highlight that colleagues at AFBI, Rachel Carlan and Joel McElvoy, have conducted a review of this. This is just a copy of the review which was produced by DERA, part of an evidence and innovation project, which goes into a lot of the details of practical strategies for reducing ammonia emissions. So finally, just some brief conclusions and finishing off. Brexit has created much uncertainty for the Northern Ireland dairy sector, especially in relation to exports. But undoubtedly, if our sector is going to survive long term and be an efficient sector, those export markets must be maintained and we need to develop new markets. To do that, we need to produce a product that we can market as having produced to the highest standards, including high environmental credentials. But there are considerable challenges in allowing us to do that, not least in terms of water quality and gaseous emissions. In finishing, I would say that we need to continue to focus on developing and adopting strategies to reduce the environmental footprint of our dairy sector. Thank you very much, Chairman.